Good morning, guys. Myself, Pathak Sumit, working as assistant professor in Sinhagar Institute. Again, I welcome you in this online session. In last session, we have started the chapter Statistical Process Control from Industrial Quality and Management. In last session, we covered introduction of statistical process control, sources of variation, common causes, assignable causes, types of control charts, their difference, then X bar R chart and problem on it. Now in this session we are going to start with attribute type of charts and first chart, that is P chart. Now what we are going to learn in this, the comparison between variable and attribute charts. Second comparison, P chart with C chart and X bar R chart. Next we are going to solve two problems on it, and lastly we are going to cover how we are going to select proper type of control chart. That is, we know that there are two types of charts, variable chart and attribute chart, but which type of chart is suitable and where we are going to use it, that we are going to learn in this session. So moving towards types of charts, attribute chart, that first chart we are going to learn P type of chart. In last session we covered the difference between variable chart and attribute chart, but just here to recall that last session types, there are two types of charts, variable chart, attribute chart. Variable chart is used to measure length, weight, thickness, volume, diameter and so on, and this data is represented on X bar and R chart. Attribute type of chart, where we are going to monitor the quality characteristics just like quality, taste, smell and so on, and it is represented on P chart and C chart. Next, attribute type of chart. Attribute type of chart, it requires only a single decision, just like yes no type, good or bad, accept or reject type. Just for example, apple is good or rotten, light bulb working or not in working condition, number of broken biscuits in a cartoon, entering of plain plug gauge, that is go side or no go side. Another example, number of complaints received for a particular product. Such types of examples are represented with the help of attribute type of chart. Now comparison. Comparison of P chart with C chart. P chart is used to monitor the proportion of non-conformities with a sample, or another way how we are going to explain it, it is used to measure proportion of items in a sample that are defective one. Similarly, on other side for C chart, it is only used to count the number of defects or non-conformities per unit. Now, P chart is used when both total sample size and number of defects are computed or can be computed. C chart is used only when the number of defects but not for computing the proportion of defect. So remember this, defect is different and proportion of defective component is different one. Example for P chart, proportion of broken biscuits in a batch. Example for C chart, number of defects in bus body. Next, comparison with X bar chart and P chart. X bar chart, we know it is a variable type of chart. P chart is attribute type of chart. The cost for data collection is more due to actual dimension measurement in X bar R chart, and data collection is comparatively cheaper in P chart. Sample size is very small, just like for 5 samples in X bar and R chart. For P chart, sample size is larger one. Control limits are affected by sample size. Here, there we are not going to use control chart, so only yes no type of data is going to be recorded here. This X bar R chart is the method much superior for identifying the cause of variability. Here, this method is slightly inferior regarding with cause detection. Next, how we are going to solve the P charts related problem. So here first the main important point that we have to remember, that is P is equal to D by N formula. D by N is nothing but number of defectives divided by total number of samples. P chart is based on binomial distribution. There is also one upper control limit and lower control limit, and formula for that it is P bar plus 3 sigma and P bar minus. If the lower control limit value is negative, then set it to 0. We know that always this step we follow for X bar and R chart also. One problem based on it. But now before solving this problem, I have to inform you one thing. This problem is based on varying sample size. Varying sample size, it means this is the sample size which is varying. Another problem again we are going to solve, which is based on fixed or constant sample size. So first, problem number 1, based on varying sample size. Let's consider that first column is related with number of days, second is related with samples, defectives. This much of data is given in exam also. We have to find out fraction defective, and for fraction defective we know the formula: total defectives divided by total number of samples. In this problem, the days is represented in first column, second column sample size, third column defectives. Now fraction defective is calculated by dividing D by N formula, that is defectives divided by samples, and here we will get fraction defective value. Say for example 5 divided by 110, we will get answer 0.0455, and similarly we will find out for 10 days. Now let's consider that this problem is related with number of broken biscuits on daily basis. For example, on one day the sample size of 110 cartoons going to consider, out of which we will find out 5 boxes defective one, or second day 180 cartoons have been taken as a sample size, out of 8 we will get defective one, and similarly. Now here we will find out the value of p bar, that is total defectives divided by total sample. Total defectives are 79 cartoons are being defective one out of 1640. It means the value of p bar is 79 divided by 1640, we will get answer 0.04817. Now for sample size, the sample size is varying sample size. It means the data which we will consider on daily basis, that is from day 1 to day 10, it is a variable type of data. It will starts from, say, for first day 110 cartoons are being taken for inspection, second day 180 cartoons, third day 150 cartoons, and so on. And out of these number of defective cartoons are being observed. So as this is a variable type of data or variable type of sample size, so we are going to consider n bar, that is 1640 divided by 10, and we will get here sample size 1640. Now after that, moving towards our control limits, that is p bar. Formula for it, formulas for that control limits: upper control limit, lower control limits, and here all the data is calculated. According to it, the graph is plotted. Now here we will plot the graph on y-axis fraction defectives and on x-axis number of days. So accordingly we will point out the data or point out the fraction defective numbers on the graph. Before it, we will represent it as usual, as we did in X bar chart also: upper control limit and lower control limit shown by dotted lines. As value of lower control limit is -1, so we will consider it 0 and we will put it and we will mark it. Now here the main point that we have to remember, that is the value goes beyond control limit. This value, that is 0.1056, this value goes beyond upper control limit. Now just recall our last session. In that last session, what we shown, that when such types is there, then this occurred only because of causes. We know that in session we learned there are two different types of causes, that is assignable causes and common causes. And here in this slides we refer that when the value goes beyond control limit, then it is only because of assignable causes. It means these causes are being identified and eliminated, right? So this is the observed, or this is obtained during the day 5, and it is because it means these 19 defective cartoons are being observed or are being identified. Cause is being identified and eliminated. Here we have to take proper precautions, proper instructions to operators while packing the biscuits, and so on, that we have to carry out. Next, second problem. As I told you, the first problem is related with varying sample size. Now second problem is related with sample size, which is a constant one. We can easily observe the, which I have actually taken from one reference, that is classes engineering wrist.edu, and this is because presently due to this corona, the whole world is suffering. I have limited resources with me just in terms of books, so I have referred these problems from Google. In this second problem, there is a sample size which is constant sample size, that is 50. Then number of defective cans is given, fraction defectives, and total samples considered are 30. As we know, as per our last session, we have find out the number of non-conforming can. For sample number 1, we will take sample size of and number of defective cans. Say defective cans means there is a orange juice, cans of orange juice. We will find 12 cans defective. Then in second sample, out of again sample size constant 50, we found 15 defective cans. On sample size third, we found again 8 defective cans or non-conforming cans, and sample size for always we will consider that is this number of non-conforming cans are obtained when we inspect 50 cans. Out of 50 we will get 12 defective, out of 50 we will get 15 defective, we will get 8 defective, 10, 4 and so on. Again the same formula, that is 12 divided by 50, we will get non-conforming fraction data. Again 15 divided by 50, we will get fraction defectives. Here also I have mentioned it with the help of one hint. A sample number 1 contains 50 samples of juice can, out of which 12 cans are defective and non-conforming, and similarly this process is carried out for 30 samples. Again we will use here same for P bar, total defectives divided by total samples, that is 347 divided by 30 into 50. Now see here, sample size which we considered in last and here is quite a different one. If we see in last session what we did, we will add all the samples because this is a variable sample size, and then we will add defectives, and from it we can find out value of P bar. But here total defectives here we will get 347 and sample size that is 50, that is multiplied here, and we will get value of P bar. Now we have to find out upper control limit, lower control limit. After that again put it on graph. On y-axis we are going to put fraction defective, on x-axis sample numbers, and from it the points are marked and joined continuous line. Remember, upper control limit, lower control limit, we are going to use dotted lines for only our understanding. But in industry, when we are going to plot a chart, there are always continuous lines. Same thing here also. When the data goes beyond control limit, then we can easily conclude that this is only because of assignable causes. Here, conclusion is also mentioned. When the data goes beyond upper control limit or lower control limit, then it is only because of variation due to assignable causes. Now, assignable causes that can be identified and eliminated. As we know in the X bar chart, in last session also I have mentioned you. Here my previous video link is also given to you. Just refer it and you will get details about it. Now, moving towards the next point, that is how to select proper type of control. When we are going to see X bar and R chart, then first of all, selecting the proper type of control chart. First, X bar and R chart. A new product when is being manufactured, at that process we are going to use X bar and R chart. When the process operations for some time is there, then we are going to use X bar R chart. And these are the various points for which we are going to prefer X bar and R chart. Similarly, if we see the attribute type of chart just like P chart, C charts and U chart. In following situations, we are going to consider the P chart attribute type of chart. Say for examples, office automation equipments, automobiles, the major systems, when the process is complex assembly operations and product quality is measured in terms of occurrence of non-conformities, that is successful or unsuccessful. This is also one again best example for it. When process control is necessary but measurement data cannot be obtained, in this case we are going to prefer attribute type of chart. It means whenever data is not obtained but we will get the data in terms of yes, no, accept, reject, good, bad, then we are going to prefer attribute type of chart. One main point we have to remember related with attribute type of chart is these charts are inferior to the charts for variable. Always use X bar and R chart whenever possible. See, if we see in most of the manufacturing sectors also, we will more rely on variable type of chart instead of attribute type. These are the few references. Due to corona, I have referred online materials for you and presented in front of you. Thank you.